The UrbanTEP platform is a virtual, open, and collaborative environment which brings together Earth observation and non-Earth observation data, computing resources, tools to support data exploitation in terms of data processing, data mining, data analytics, algorithm development, collaboration and communication, and marketplace functionalities. So this means that pretty much that the UrbanTEP is not just a project, but a platform service, let's say. The UrbanTEP allows third-party data and service providers also to develop and offer their products via UrbanTEP platform. It allows experts and non-experts users to use these services and further develop them. For any third-party service providers and end users, UrbanTEP offers development and processing infrastructures as well as basic services. So in this presentation, I will briefly address the most important existing services and the current capability evolution functionalities. But first, let's start a little bit of history to put it into perspective. So European Space Agency started in 2014 the Earth Observation Exploitation Platforms Initiatives, a set of research and development activities that in the first phase up to 2017 aims to create an ecosystem of interconnected thematic exploitation platforms. So in short, these so-called TEPs on a European footing and addressing a number of thematic domains. So that means the coastal, forestry, hydrology, geohazards, polar and urban themes, and the food security. So in those respective terms, the 7 TEPs were created. So the forestry TEP, polar TEP, food security TEP, geohazards TEP, coastal TEP, hydrology TEP, and the urban TEP we are focusing on today in our presentations and the introduction to its functionalities. So in short, this Earth Observation Exploitation platform is a collaborative virtual work environment providing access to Earth observation data and the tools, processors, and informations and communication technology resources required to work with those services, but all through one, let's say, the coherent interface of a single platform. This slide illustrates how the entire, let's say, the TEP ecosystem looks like. You can see a set of this TEP platforms with the yellow background that provide this community workspaces for scientists, researchers, let's say the decision makers, and many other types of users. A layer on top of it, on top of these TEPs, is intended for specialized tools, let's say, that can be leveraged by TEPs for the data exploitation, like the UrbanTEP's Gisat tool that will be presented later today. Then, for example, EO4SD Lab, Earth System Data Lab, Ocean Virtual Lab, and many others. Within the layers under the TEPs, you can see the number of services and the platforms providing these services, like EuroDataQ, Jupyter Hub, ELIP platform, ASB framework platform, Google Earth Engine, and this provides the additional services and access also to another data repositories, data archives that are being utilized by these TEP community platforms, let's say. And finally, on the lowest level here, you can see a set of, let's say, the specialized infrastructure platforms, including number of, or let's say, the wide range of services in terms of processing capabilities, access to a range of these data repositories and archives that are being utilized by the TEPs, And this also includes, as you can see, these so-called DICE platforms, data and information access services like Vekeo, Creodias, Mundi, Onda, Soblo, and also other platforms. So let's say the infrastructures from Google and also the Amazon. So this is just a, let's say, the brief overview of this entire Earth observation based ecosystem around these TEP platforms. So in terms of motivation, the Sustainable Development Goals, or SDG in short, is a collection of 17 interlinked objectives designed to serve as a, and that's a quote, shared blueprint for peace and prosperity for people and the planet now and into the future. So this 2030 Agenda for Sustainable Development was adopted by all United Nations member states in 2015. And these SDGs focus on poverty, hunger, health, education, equality, clean water, energy, and many other say the thematic domains here. So in terms of this urban context or this urban thematic domain, here is the list of possible challenges where this Earth observation functionalities can contribute to these challenges, and this is also how platform like UrbanTEP can help in these respective areas. So the UrbanTEP is a platform that provides you with data and tools in one place and with ready-to-use end-to-end solutions. So in terms of data provisioning, it provides you with an access to various data sets like Copernicus Archive, Lancet Archive, and various other so-called, let's say, the added value data sets that are the geospatial products derived from those original data sets. And what's important to mention is that you can also upload your own data sets to the platform and make them available for you, your community, or let's say also publicly. UrbanTEP enables access to different processing environments, including different cloud solutions where you can execute the available processing services, for example, to generate your own products. Also, the platform offers extensive analysis and visualization services to analyze, exploit, and to visualize the data available on the platform, and again share the results of your analysis with your colleagues or your community. And as the UrbanTEP platform is also a community platform, it provides functionality for the knowledge exchange. So the idea here is that the users, developers, stakeholders, planners, decision makers can come together, develop ideas, develop thematic processors, products, and services directly on the UrbanTEP platform. In terms of user community, our target groups are analysts, scientists, just like I've mentioned in the previous slides, as well as service providers, which develop new algorithms on the platform and make them available for spatial planners, decision makers to derive the new Earth observation-based information for the urban community. So in terms of the users and let's say how the UrbanTEP platform is popular, in the latest years, we've had more than 600 users from more than 50 organizations, requesting access to Earth observation data from the UrbanTEP platform, but this number will be in the end much bigger currently. And on the left side of the slide, you can see our list of let's say the UrbanTEP key users, or let's say the stakeholders, which contains the World Bank Group, UN Habitat, UNDP, United Nations Development Program, the Organization for Economic Cooperation and Development, World Food Program, Gates Foundation, Group on Earth Observation, and others. So in terms of the actual UrbanTEP platform, you can find it on the link you see on the top of the slide. So on the website urban-tep.eu, and this is the landing page for the entire platform. Okay, so as I was saying, this is the landing page of the UrbanTEP platform, and from here, the users can enter the community workspaces, which allows the communication between the communities, the colleagues within them, and the joint development of projects in a, let's say, the open or closed manner. The middle part is focused on the data and products showroom, and the third most important part here is the Earth observation processing services. So we will get through these in a minute. So first, a brief introduction about data products hosted at the platforms. We have a very broad range of data products available on the platform. And as part of this, this general introduction, I will give a very brief overview of what is available. And in the follow-up section, I will focus more on the World Settlement Footprint, which is one of our, let's say, the flagship products in the suite containing our flagship products. So let me introduce just some basic EO, not basic, but EO-based products. We provide access to different data sets that are being provided mainly by the European Space Agency, from the data sets like CCI, Climate Change Initiative, to night lights data sets, and also, as I've mentioned right now, our own let's say the user-developed flagship products like Global Urban Footprint and the World Settlement Footprint. So in terms of WSF product, the World Settlement Footprint, this is a 10-meter resolution binary mask outlining the global settlement extent, and it pretty much illustrates the difference between a build-up and non-build-up area. It's a global product, and here you can see just the focused, or let's say the zoom in on Madrid city in Spain. Here you can see another example of the WSF 2015 product for the Beijing area, and another flagship product which is called WSF Evolution, which is derived from the original WSF data source, and it pretty much aggregates the information from the WSF over the years, color codes it into one layer, showing the let's say the aggregated settlement evolution throughout the years from 1985 to 2015. So in our opinion, this spatial and temporal component makes this data source really interesting for analysis, and makes for a rather valuable data source. Another example Shanghai. And here you can clearly see the original settlements that were built up until 1985 in red, and then color-coded additional developments throughout the years until the final year 2015 in a purple color. Another example of the WSF evolution, now we're focusing on Dubai, and what's worth mentioning is that here you can clearly see this point of interest, this artificially created island in Dubai that was built sometimes around the 2004-2003 year. Okay, going back to the landing page of the platform, let's now look into the community workspace part of the platform. So clicking this link will take you to a so-called community workspace, where you are able to request access to an existing communities or create and manage your own ones. There's a notion of a so-called community manager, which is kind of a community admin that's managing a specific community and is pretty much responsible for handling the activities within this community. As you can see on the screen, the communities can be either public or private, based on your own requirements. And in terms of newly registered users, you will be automatically part of this so-called starter users community. And here, this is designed in a way that it should provide you some basic information about how to work within the community, how to work with the platform. So it provides you an access to community applications that are available there, also to processing services. So this is something that we are calling thematic processors in the scope of the UrbanTEP. And also, as you can see, the useful links for the tutorials, webinars, information about the data collections. You can contribute to the discussions within the communities. And on the bottom part of this page, this is not shown here in the image. There you can also see the progress of your ongoing, let's say, the computations or running processing services. So if you run some thematic processor within a specific community, you can monitor the progress also on this page. Another part of the platform is designed for the Earth observation processing services. So this will take you to a so-called EU browser, where you can access the number of different data sets. So here on the top right side of the screen, you can see the EU data select box, which enables you to get access to different satellite image archives from ESA, mainly Sentinel-1, Sentinel-2, and Landsat archives. Here you can see let's say the latest available data that's being uploaded to those archives that are in the end available to you within the UrbanTEP platform for your own processing. And also, apart from this archives, you can also get access and use the data sets, or let's say the in-house UrbanTEP data sets that were developed that I've briefly mentioned. So this world settlement footprint, also, for example, the time scan data source. So here you can get access to the data and in the end to the available thematic processors that are utilizing those data. The next part of this processing functionality is this let's say bring your own algorithm evolution that we've done in the scope of the UrbanTEP, which allows service providers and users a high level of flexibility by guaranteeing the portability of their developed processors, thus avoiding the single dependencies with the specific platforms or services. So what it does is it basically, let's say, decouples application developers from specific exploitation platform operators and from the application consumers. So using this approach, you are able to create a thematic processor, upload it to a specific platform, for example, UrbanTEP, but the way it's being handled is that the application is containerized, registered in a container registry, and reusable also on other platforms, and in the end able to run, or let's say to be executed on a different underlying platforms. So in a different, let's say, this cloud infrastructures, these DIaaS services. But this will be the topic of another part of today's webinar. So going back to on-demand processing services, this is what I've mentioned in relation to this thematic processors. So in this your browser, you will get access to a number of thematic processors that are available to the users of the UrbanTEP platforms. You can develop your own processors, share them within the community publicly, or make them just private for you on the platform. And here on this screen, you can see, for example, the regional statistic processor, which is focused on the spatial temporal aggregation of raster data and regional statistic for a set of regions. So you will select this processor, fill in the required parameters, so datetime information, area of interest, input data set, and just make the execution, or let's say make the computation with this thematic processor. And then in respect to this community workplaces, then you can share the results of your analysis, your computation with other colleagues. And the last part is data products and showroom. This link takes you to a Gisat application, which is the visualization and analytics toolbox, which is a data exploratory tool. It provides access to all of the data hosted by the UrbanTEP platform. It enables the in-depth analysis and statistics in the form of so-called scopes. You can see those on the left side of the screen. So these scopes are in effect, say, projects developed for certain stakeholders. So you can see here let's say the in-house UrbanTEP scopes, EO for SD ones, and one designed for the World Bank Group. So a couple of quick examples of these scopes. I won't go into detail here because I'm not the domain expert here, but also this Gisat tool will be the main focus of one of the next parts of today's webinar. So just to give you let's say a taste of what's available on the UrbanTEP platform. So this is the building inventory and monitoring example for the Kigali, which is the capital of Rwanda, and the comparison between the years 2009 and 2015. with the underlying, let's say, the underlying information regarding the sectors. Next example is the green urban area inventory, or let's say the tree cover example for Oslo, Norway, where you can see the metric, which is this tree cover, and you can compare it between specific Oslo areas. Next example is focused on the sustainable development goals in respect to indicator 11.3.1, which is the well, let me say it this way. It combines the population development and the settlement footprint layer to show this indicator that represents the population change normalized by the settlement area change. So this means that the higher the value, the more the settlement growth outperforms the population growth. And using this indicator and using this Gisat tool, you can see the results visualized in map interface and also in diagrams or in-depth statistics. There are also more advanced scopes available. This one is for Prague, and is a customized scope that lets the users change the type of land cover within the urban environment and model the urban climate related to those changes. So you can see here this V-shaped part, which is being changed to urban greenery, and then to model the climate related changes. Next example puts into perspective the energy consumption and the night lights data layer. So the darker the color, the more intense are the night lights per capita. And for example, putting it into perspective with a number of geotagged tweets per capita. Next example, the urban population share in perspective to gross national capita, gross national income per capita, and the last one here is the in-depth land use and land cover statistics. As I said, I won't go into the detail, but the Gisat tool gives you a number of options how to really exploit the data available within the UrbanTEP platform. So you can just visit the UrbanTEP platform and you can explore and experiment with the data that's available there. In terms of storylines, the quick introduction to storylines in the scope of the Gisat. This is the alternative to previously presented Gisat scopes, because we believe that the storytelling is, let's say, the powerful tool to be used for the knowledge transfer, specifically in this domain. So this kind of storylines makes the presented information in this Gisat scopes more understandable, memorable for the user stakeholders to understand the purpose and reasoning behind these scopes. So what it does is that it pretty much transforms the highly technical scope of Gisat into a more descriptive description in the form of these storylines. So you will get this context, or let's say the background information regarding a specific scope. And what's important to mention is that this is not just let's say the static website, but it's highly dynamic, interactive selection, and based on your selection, even in this storyline pages, the figures and the statistics adapt based on your selection and based on your analysis, let's say. Here you can see again the Gisat user interface, but now with the integrated product WSF 2019. Because it's important to mention that the data products available within UrbanTEP platform, like the World Settlement Footprint, World Settlement Footprint Evolution, and others that can be used for this as a data source for the processing within the thematic processors, can also be used as another source of information and the data layer also in this Gisat analytical tool. Latest edition in adoption, latest edition for the UrbanTEP platform is the adoption of so-called data cube technology. So here the data cube is actually a data format that enable users very effectively derive information from a multi-temporal imagery and other data sets, and thus enables the service providers the creation of more advanced services on the platforms. Here you can see the Limassol showcase and the NDVI vegetation index analysis in the scope of this so-called X-Cube functionality or city data cube, and another one for the plant phenology index. So again, just a rather brief introduction about this functionality, because it will be the content of the follow-up time slot of today's webinar. So in terms of the next steps, the UrbanTEP introduces the concept of this so-called city cubes, and the access to the Euro data cube will be added as infrastructure that can be accessed via the UrbanTEP platform, via specific urban services and data provisioning services. But as I've said, this will be the content of one of the follow-up parts of the webinar. So this is for the general introduction of the UrbanTEP platform. And now let me show you the presentation for the next part, focused on the World Settlement Footprint Suite. So yeah, let's pick up from my previous talk. So this WSF suite was developed the German Aerospace Center, DLR, in collaboration with ESA, World Bank, and Google Earth Engine. And it contains a collection of novel, open, and free high-resolution global data sets. In particular, includes the 6 different data sets listed here: the WSF 2015, WSF Evolution from 1985 to 2015, WSF 2019, 2019 Imperviousness, and 2019 Population, and the WSF 3D. So we will just quickly go through them in this presentation. So the first flagship product here is the World Settlement Footprint 2015, which is a 10-meter resolution binary mask outlining the 2015 global settlement extent derived by jointly exploiting the multi-temporal Sentinel-1 radar and optical Landsat 8 satellite imagery. This product, or let's say the data set, proved to be the most accurate product of its kind, as assessed based on almost 1 million validation samples collected by crowdsourcing, photo interpretation of Google Earth imagery, and specifically it proves capable of reliably outlining not only the major cities, but also suburban and rural areas where still about half of the global population is estimated to be living. Just a couple of slides to illustrate this data set. So here you can see the example for Asia and the main cities in China, Japan, Korea, Taiwan, Philippines. Here's the example for the South America. You can see here the Buenos Aires in the south and Rio de Janeiro more to the northeast. Here you can see the North America with the East Coast, the Chicago and New York, and on the West Coast, San Francisco. Europe with you can clearly distinguish the London, Paris, Moscow, for example. South Africa with the focus on the Johannesburg city. Let's move to the next one. Here you can see the examples of Dar es Salaam in Tanzania. This layer looks yet at the first sight quite accurate and reliable. However, thanks to the availability of Sentinel-2 data and further improvements in the underlying approach in the past months, we've been able to generate this 10-meter resolution novel data product called World Settlement Footprint 2019, which exhibits even higher quality and detail, as one can clearly appreciate the crisp and cleanness of the zoom area here. And this was also supported as well by an extensive validation based on about almost 800,000 crowdsourced labels. Here you can see the WSF 2019 comparison of Lubumbashi, Congo, Karachi, Pakistan, and Port-au-Prince from Haiti. So you can clearly distinguish between the urban and non-urban areas here. So in terms of a validation exercise, the products are validated. So for WSF 19, almost 800,000 validation samples were collected by crowdsourcing, together with 200 very high resolution Google Earth satellite aerial images acquired in 2019 that were used for the validation. The validation exercise 2, so these are the blue dots, let's say, on the map. These were here over 200,000 validation samples were collected by crowdsourcing and 50 VHR Maxar satellite images. And here's the validation exercise and the assessment criteria. There were 3 used for the final validation. The first one used parcel matching. second one per block matching with the majority rule, and the third one per block matching, but with the condition that the settlement, it's a settlement if at least one cell is a part of the settlement. So, and the similar approach for the validation exercise number 3, which was performed through GeoWiki application. Over 3 million validation samples were used and collected by crowdsourcing again, and 50,000 locations used from the Google Maps. And pretty much the same approach to the assessment of the criteria. And here in the, let's say, the final comparison table, you can see this kappa coefficient, and you can see that the this let's say validation of the WSF 2019 data product outperforms any similarly themed data products. Just a couple of showcases and examples of this flagship product. So here in this framework, we've generated the WSF evolution data source, which is let's say the revolutionary data set that outlines on a yearly basis the growth of the settlement extent globally at 30-meter spatial resolution from 1985 to 2015. The WSF evolution has been derived by processing the entire Landsat 5 and 7 archive, and based on more than 1.2 million validation samples, it in the end outperformed any other similar layer presented so far. The example here for Dar es Salaam gives an idea of its potential in characterizing the settlement growths. Another animations, the comparison of Bangkok, Indianapolis, Cairo, and New Delhi. Here's the showcase of the Per River Delta in China region with that's the region with massive manufacturing and trade, and most of it is heavily built up and densely populated area. Here's again the example of the Dar es Salaam, which is the Tanzania's largest city, and has become one of the East Africa's most important ports and trading centers. Nairobi city, which is a capital of Kenya and probably the biggest transit point there. Conakry is the capital of Guinea and the economic, commercial, and trade center for the area located on the peninsula. Durban is the third largest city in South Africa and the busiest port in Africa. Los Angeles in California's most populous city, and the second most populous city in the United States after New York. So here you can see that the most of the settlement was built until in 1985, as denoted by the red color. Sao Paulo, which is the largest city in Brazil with a municipality population of 12 million. Here is the Hue, middle-sized city in central Vietnam and the former imperial capital. So this is the illustration of the WSF data source for each respective years and the aggregated WSF evolution layer for the same place. And yeah, here you can see the Hanoi, and the difference between the WSF evolution version 1 and then the later updated version 1.1. As for the evolution product, a validation was also conducted. So as I'm slowly running out of time, I will just really quickly go through it. So you can see the validation that was conducted on 600 VHR Google Earth images using 6 time steps for 1990, 95, 2000, 2005, 10, and 15. And the resulting coefficient, as you can see, also outperforms any similar data set available. What's worth mentioning is that the Landsat data availability varies across regions and over time. So whenever it's poor, this might prevent a good quality of the WSF evolution. So to make this rather transparent to the users, we've defined and computed so-called the input data consistency score. So this IDC score, which characterizes the goodness of the input for the Landsat imagery for each target year. And this score ranges between very low to very good, and it might become a key tool to better interpret the results of any integrated analysis here. And here on these graphs, you can see the comparison between the Egypt and Gambia, which is the region in Africa, and the quality of this IDC score for this type of region, where the Egypt has a pretty good cover from 1985 up until 2015, but for the Gambia region, the coverage is let's say pretty poor up until 2000. Next flagship product is the WSF imperviousness. In this regard, we've aimed at estimating the percent impervious surface, which describes for each pixel the actual portion on the ground covered by paved surfaces, and is considered as a good proxy for the building density. So this resulted in the WSF 2019 imperviousness layer, which we expect to become of a high support for several applications. For instance, characterizing the urban heat island phenomenon, or assessing the risk of urban floods. So to give you an idea of how relevant the datasets could be for characterizing urban morphology, let's consider the 3 regions. Here you can see the Kinshasa, Brazzaville region, Dublin, and Bangalore, while the corresponding total settlement extent is quite similar. They show completely different imperviousness patterns. Bangalore exhibits in general pretty high values everywhere. On the contrary, Dublin, a part of the old city center and industrial sites, is associated with rather low values, whereas in Kinshasa and the Brazzaville, we can see a gradient from the densely built up city centers to the suburban regions or outside to the city. Last but not least, the suite includes the WSF 3D layer, which is kind of a unique of its kind. It allows estimate globally at 90-meter resolution the average building height and volume based on the 2012 TAN digital elevation model X, thus facilitating unprecedented environmental analysis, let's say. So here you can see again the example of Dar es Salaam from Tanzania. The high-rise buildings in the central district emerge quite clearly, as well as those located to the major road connecting to the airport. Here you can see the version 1 of the WSF 3D product with 90-meter resolution for Madrid. And then based on data with much higher resolution, here you can see the version 2 of the product of WSF 3D, which is based on these original data sources and resulting in a 10-meter resolution of the final, let's say, the data product. So to summarize, here is the showcase of the Paris with the let's say the interconnection of the different data sources and data layers available here, and to what you can do on the UrbanTEP platform. So here you can see the total population per admin unit layer, the WSF imperviousness, and the 3D version of the WSF. So if you put it into perspective, here you can see the population distribution among the zones using the WSF 2019 settlement extent. Here you can see it extended by an additional data layer ancillary building use mask. So this ancillary structure is a common term for structures that are ancillary, or let's say the supports to a principal dwelling. So these structures include, for example, carports, garages, sheds, pergolas, and this type of structures. Here you can see the population redistribution with the utilization of WSF 2019 imperviousness together with this ancillary building use mask. And the last one that uses the imperviousness layer together with the 3D version of WSF data source with the ancillary building use mask. So you can stack all of those data sources, data layers on top of each other, and as per your requirements and your goal in the terms of what you want to achieve. So let me conclude with some of the milestones here. In particular, the data products, the WSF 2019, 2015, 19, and evolution, and the 3D version are already available, open and free. So you can download it from respective repositories. WSF evolution, but the upgraded version 1.1 is now undergoing. It should be soon available, as it was prepared and the validation is complete. So soon it should be available in these repositories. WSF 2019 imperviousness is product, as you've seen the examples and showcases, is also completed, but the validation is still ongoing. And the last one, the population layer, this is being completed in the follow-up, let's say, days and weeks. So soon again should be available on the data repositories, but also in the scope of the UrbanTEP platform to be used for thematic processors. So let's say for the in-depth statistical analysis and data exploitation via the Gisat tool. And that's it from my side, from the WSF suite part of the presentation. So if there are any questions, feel free to ask. Just a reminder that I'm not here a data expert regarding this data product. So if you have any let's say the specific data source related questions, feel free to address them via this contact@urbantep.eu support email, and this will get you in touch with the correct person to handle your question. Okay, so now I will give the floor to the colleague of mine, Pedro Gonçalves from Terradue, to present the next part of the webinar, the algorithms and processing infrastructure capabilities of the UrbanTEP platform.
Thank you very much. Now at this in this next half hour, I'll make an introduction of the capabilities of the UrbanTEP in terms of, as an exploitation platform, to do algorithm hosting. So it means that its capabilities in terms of hosting different applications and different algorithms that are processing data in the context of the UrbanTEP. We see Earth observation applications as a little bit more complex of just scripting data or accessing information. In this case, the Earth observation applications is more a set of command line tools that have numerical, textual, and geodata parameters, and organize it as a computational workflow. Each application has specific inputs and outputs and environment needs, and it can orchestrate several command line tools. And here, our main drivers is that we want to guarantee that the applications are capable of being automated, scalable, reusable, and portable into different infrastructures, so that we are not stuck into one cloud provider, and we are not stuck to a specific workflow engine or a specific environment. And so for this, the main drivers was really to see how do we create an environment, how do we help the researchers, the application developers in this area to decouple the application development phase that they have with their own platforms, and having a common way to serve that information to application consumers. So it's really allowing the developers to focusing on application development and not worrying about how the platform specific information appear, and also having a way that you could run it on a platform like UrbanTEP. But if you wanted to run in your own cluster or your own computer or your own workstation, that you are able to execute the same application in several execution scenarios. And so this was from the developer point of view, but also from the platform point of view, we wanted to allow UrbanTEP to really be able to support any type of package application and not just a fixed set of environments. And so we've been working with the Open Geospatial Consortium for a long time, and we defined a best practice for how to do the packaging of Earth observation. So the best practice for Earth observation application package that defines guidance in terms of three main viewpoints. In the sense, how did the developer adapts an application, our integrator is able to package it, and our platform is able to deploy and to execute that application. This work was done a few years ago, and with lots of supports and submitted from different companies, and we started to focus on this, really extended it to and a wider term to focus on reproducible open science. So in fact, that we are using the application package in terms of the reusability of algorithms and workflows, and the portability and the transparency, so that we are able to organize the different applications in such a way that we are able to allow it to be reproducible in different environments, in different platforms. And so, as Václav mentioned before in the same slide, we have enhance the UrbanTEP in terms of the algorithm hosting. So in the sense that we are able to accept an application, so it would be a Python, a shell script, C++, that is containerized and registered. We document that application or the set of applications with the common workflow language that I will go a little bit more in detail afterwards in this training. And then we are able to use that common workflow language as the basis to deploy this as a service, as an OGC API response. And so using this document, using this common workflow language packaging, and using a set of specific best practice in terms of the data streams, we are able to allow this several type of applications to be portable and deployed in different environments without a specific locked in. So what it is, the common workflow language. Common language is a specification for describing analysis workflows and tools. It was really sought to different environments, not only web, not really specifically the web environment, but was more also to clusters, to workstations, to cloud, to HPC environments, the way how do you package an application to focus on the way to describe its processing. Initially was really designed to meet the data intensive science like bioinformatics, medical imaging, astronomy, physics, and chemistry. And the work we've been doing is, okay, how can we adapt this work and this type of specifications into the Earth observation, into the Earth science domain? And so basically, you have a JSON or a YAML file, but it's really quite straightforward. You are able to say, okay, you create a container with your application, or you have a script with your application, and you just say, okay, this is my workflow, this is my command line, these are my parameters, and you can give information about it, and then to show how this will be executed afterward in your environment in the command line. You can describe applications in sense of service descriptions, the input interface, everything it's allowed in sense of describing your environment in terms of the common workflow language. And then this information will be used when we are hosting it on the platform to describe to the user which are the parameters that it needs to use. So in fact, it's a way of almost you giving access to a command line interface, or you have access to command line interface parameters, but using it and the web interface that Václav showed before. And this, then you can have different types of parameters, different types of workflows, and even defining what is the output that you are producing here. So this is really a high-level view of how you can define your types of applications. You can use containers, but also you can use directly Python code. So you want just to be able to create a new service in the UrbanTEP that is just a specific container or a specific Python code using that information that you want to send it back to the user as a web service. You have the possibility also to call. You create a container, you create the environment that you want to call, and then you are able to really go and call the specific command line that is in your container, defining the environments. And so you're really entering into a world of providing an interface to your what you normally do in your own computer, but to as a service. And so it's in all the command lines that you are putting there. Then one big advantage of CWL is really that you can build on top of it. So you have a small, imagine you have a small command line that does something. You have this in one container, you have something else in another container. And with CWL, you are able to start orchestrating this, doing this type of computational workflows in different steps. Could be in a single container, could be in different containers. So you are able to really to wake up different machines that are being driven into code your more complex workflow. And you can define steps for each of the execution parts. And also a really important thing is that you can define different requirements in the sense, oh, this block here really needs GPU, or this block here really needs every part of memory, or this one can be divided into parallel tasks to being executed. So it's really quite a flexible way to define your processing chain. So this is really to when you are having an every processing algorithm, and you really want to put it as a service available for the community. In terms of data management, the work we've been doing in the best practice in the OGC is really to define a way in terms of or best practice in terms of using the spatial temporal access catalog stack to describe the EU data inputs. So you define this as your manifest, your data manifest, that really says, okay, these are my inputs, and then the platform is able to stage in the data and then send it to the application that is running. The stage out is the same, that when your application is creating a stack item that really describes what are the different assets that were created as a result, and they are stage out from the results of your application to give access to the platform, then to be able to display it in the outside world. So the algorithm process that we're putting in the UrbanTEP, the algorithm hosting process, is really people are developing their algorithms. They can be complex workflows. They can be developing it in different languages. They can be developing it using different containers. Following the OGC best practice and the Earth Observation Exploitation Platform Common Architecture from ESA, which CWL documents are able to package that application. There is a data integration step in the sense of to understand the best practice and how do you accept the input data, how do you accept the output data that needs to be done in that part. And then algorithms are deployed and made available for users in applications in the various domains. Then what Václav was showing, the different communities, you can assign that service to a specific community into a specific cost model. The good thing about this, that's very important, is that you have a continuous support and update. So if you have your code in a GitHub, you have building of the containers and registry optimized, and you have the deployment in the UrbanTEP in a continuous integration pipeline available for your users. So basically what we have is in a diagram, the same text but in a diagram. Okay, you have the data, you have your algorithm in a GitHub, and currently what the UrbanTEP allows is that, okay, let's put that GitHub, let's put those contents, let's do the algorithm, the application packaging, and then we are able to make it available as a processor to a given user. So given that information, that code that you put then becomes available. And this code can be very complex or simple, or requiring different types of processing. And you are able, in the application package process, you're able to define those types of needs. To give you an example, just a quick one, we were using this as an example in the past months, just developing an algorithm for the green city, greenness, that detects urban green spaces, basically an NDVI-based threshold from optical calibrated datasets. We were doing is okay, let's do an algorithm, multi-mission algorithm that could accept Sentinel-2, Landsat, or Spot, or Pleiad, or Pleiades-Neo, and so on. And the workflow was a little bit more complex in the sense of, okay, radiometric calibration, extract assets, compute NVI, produce a binarization. And so we did this as a test in terms of the application package, and the output is it's an 8-bit RGBA. And so the examples here was, say, okay, you have that code, you are able to deploy it, and then it becomes a service that is available on the TEP Urban portal. And so, for example, then you could execute it using Playad that is available on the platform. You have the results, you have all the information that is given. Or in another example here, quite important, you can then start mixing that information, the results that you have with the data that Václav was presenting about the world settlement footprint. And then you can say, okay, for example, here we are using the results visualization for 2017 in Dubai, and then you see the greenness, and then you see the evolution to 2019. So you can really start playing around in this. Here is an example also in terms of multi-mission that we are using Sentinel-2 for 23, but then we can use also the same with Playad and check with more detail. So the same algorithm being deployed being executed with different data. Just some examples here. All this was put in the these capabilities, these new capabilities. It's available now on the UrbanTEP NOR offering, so the network of resources. This was updated recently. We updated the offering there in terms of using also more services for the TEP, and most importantly to really support this onboarding of new applications, of new services that can be hosted on the TEP Urban and made available to specific communities in a pay-per-use mode or in a sponsored mode. So in the sense that we could enter into you bring your own application and you have a sponsoring to give it to a specific community, or also bring your application and make it available into a revenue sharing process in the TEP Urban. There are 3 new service offerings in the TEP Urban nowadays. One is for multi-mission data hosting. There is one specifically to support the algorithm integration. So this is really targeted to developers that want to adapt and package their existing algorithms to exploit a production cloud. This is on a monthly subscription. And operational algorithm hosting, in the sense that when you have a package of algorithm, when you think it's good to be given to a given community, this is really targeted for service providers who want to deliver that service. And it's in a flex pay per use. So the number of executions that is run, it's the cost that is calculated in terms of the processing. So thank you very much. Thank you very much, Václav. I think I'm covering it all.
Yes, thanks a lot, Pedro, for your presentation. And any questions for Pedro regarding this algorithms and processing infrastructure part?
Like always, yeah, they can contact us, and also giving into the NOR website and being more information about this type of services. Thank you.
Yes, definitely. Okay, so thank you, Pedro. And now let's resume with the next session, focusing on the Gisat analytical tool. Tomas, I see you are connected. You should be able to share the screen. So the floor is yours. Thank you.
Good morning. My name is Tomas Soukup. I'm from Czech company Gisat. We are partnering with the other colleagues in UTEP development. And in my part, I would follow up, let's say, the overview of the capabilities of UTEP. I mean, Pedro presented algorithm hosting capabilities, and I will present in my part the exploration, visualization, and analytical functionalities. Because it was announced as a training, I will try to present live. So I apologize as usual. Anything can happen in live presentation, but I found it more, let's say, more close to training, which was initially our idea. So Václav already outlined a bit in the morning session what the Gisat is about, but I will just remind the main points or the main rationale why we are working on that. The first is that we have a lot of data on platform, and let's say number of global data sets is growing. And from the intro of Václav, you have the, let's say, idea that we are really targeting the global data sets also because our main users are the global organization. So obviously these data sets are huge, and we need to allow the users to work with these data easily. So that's the first rationale. And the next one is to allow the user to explore the data before they will use, I mean, themselves as downloaded or on the platform, for example, for some algorithm, for some calculation, to let them explore the data easily before they will basically do something more with the data. And the third main rationale was to build either generic or on-demand applications which can extract from the huge data the information which are useful for the users, for the decision makers, because we are not serving only the technical people, so not all people basically are ready to run some algorithms, to use the data themselves in some analytical tools. So the idea was to provide the environment and generic or custom applications which can extract from these huge data some useful information. So that's basically the rationale of the Gisat, which stands for Visualization and Analytical Toolbox. And saying that, basically we have the three main elements, the data sets, which deals with the management of this huge pool of the data which we are collecting regularly or on demand also, and try to make this collection up to date. Then we have a collection itself, which means that the user can prepare their own collection from the large overall collection. He can select the data he's interested in and basically build their own collections. And then we have applications, which are the list of the applications which are currently available on the platform. But the idea is that the number of these applications can grow, because one important point is also that Gisat is not only what you can see in application, in data, in collections, but it's also the framework in which we can easily build the new application, the new view on the data. Maybe a little bit or few words on the technical side. I will not go into the detail, but the Gisat framework is built using the open source packages. So just quickly, this is divided on two main parts. So we have something what we call the backend services, which is a set of microservices written in JavaScript, using Node.js environment. These are Dockerized for easier maintenance and scalability. And we use here various, let's say, data sources. Mainly it used the PostGIS for the, let's say, GIS functionalities. And the complex database schemas are stored in a MongoDB. Then we have a front-end components where all these, let's say, web parts are built, which is a set of packages in React.js. It's use Redux for state management, and we use D3.js for graph visualization. Currently, we use Leaflet and Deck for the map elements, but we are quite neutral on the maps elements and can work also with some other packages. So this is just for the technical side, and I will try to go in my remaining time just a quick fly through what you can expect and yeah, just to show you how it works. And at the end, I will spend some time with some applications which are ready for exploration of some of the data. So as I said, the first part of the Gisat, as it is now, I should also say that the Gisat in last years went under the major revision. So we changed quite considerably how it looks like, but also what is behind it. First part is the data sets we have currently onboarded. Okay, it says my internet connection is not stable. I hope that you hear me still.
Yes, we can, but
okay.
For a minute it was stuttering.
Okay.
But
so it was just
perfect now.
Yeah, sorry. Yeah, my connection is not the best one, but I hope it will work. So so this is a collection of all the data sets which we have. So the user can basically somehow filter the data sets. For example, I selected the DR data sets, which were a little bit introduced also by Václav, so you already know what is about. So we can select, for example, one of the data sets. It's a word settlement footprint. So you can select the data sets. You can type which area you want to look at. For example, yeah, let's go for Beijing. And you see here live the data. You can basically see Václav already mentioned. So you can see how the city basically evolved in a different years. If you want to analyze or compare with some other data sets, you can just add. For example, we will select. Yeah, this would be a good example how also the word settlement products evolve. So I can take, for example, this one, and you can add as much of new windows as you want. So you can compare 2 or 3 data sets or 4. I didn't try more than 4, so probably it's the end. But yeah, let's see. You can add the other data sets, and you can either have a linked windows. Maybe we can try another one. Okay, let's see that. And yeah, we can add another data set, for example, this one. And yeah, and here you can basically see the different data sets which are linked together, so you can explore the same area and see how this evolve in a different data sets. Or you can swipe the data if you want, so you can really see what the data are about in a detail you need. Yeah, you can, for example, switch here. You can add the image, and you can basically understand what kind of data you have and if it is useful for you or not. That's the main aim of this dataset explorer, and this gives you the first glimpse or first idea if basically the data which you intend to use, either for your analytical needs or for the algorithm calculations, if this is something what is worth to consider. So this is about the data sets. Really quickly, I mean, what we have now, I think Václav already mentioned, but we have basically mainly global data sets from DLR, from GRC, so all the data set about the global human settlement layer program. We have a WorldPop data sets, we have a gridded population of the world data sets, and we have also these nightlights data sets, mentioning the main one. What you can do is also to produce your own collection. This is just example which I take. Yeah, for example, you can take the different versions of the WSF 2011, for example, and have a different data sets, different resampled data, and you can easily compare again which kind of data suits the best for your analysis. So again, the idea here is that you can have already your own collections, and you can just create the collections of the data you are interested in. So if we go for, I didn't mention, again, you can basically assign some tags. You can then organize your search using basically some lists, but that's quite obvious. This list of tags is extendable, so it can be tailored to your needs. Due to time, I will switch to. I have still 15 minutes, right, Václav?
Yes, exactly.
Yeah. So I will switch to the presentation of some of the application which you can already find there, and because you will more understand what I meant by the applications and extraction of information from the data. So first one is the SDG Explorer, which we did partly also for the UN Habitat. And this shows basically how you can use the global data sets for monitoring the urbanization. So you can you have defined a number of the indicators. For example, here we have a Europe, and we are testing two data sets. The first one is the WSF evolution. The second one is the GRC global human settlement layer data. And we can define number of indicators which we can basically see as a cartographic presentation, and we can compare how the different data sets, basically which story the different data sets tells you about your indicator. You can explore in detail, so you can compare the different territories, how basically the different data sets describe the urbanization processes there. And based on that, you can basically decide on some kind of reliability of the data, or choose which data you find the more reliable if you compare with some local knowledge. You can see the evolution in different graphs in absolute manner, in local or in relative manner. You can change your observation period if you want. You can change here basically the area which you are exploring easily. And yeah, if you need to export some of the chart or some of the findings, you can, all the elements which are in the widget, you can basically explore and save it, and not only as a picture but also as a JSON, or you can use it in your local environment. You can not only compare the different data sets, but you can also compare the different areas. So you can select one of the data sets you have available here, and you can select the different areas, and then you basically are not already comparing the data sets, but you rather compare the different areas around Europe, around the world, as you want. You can also select the different, let's say, granularity of your analysis. You can select the countries. You can select the regions of the countries. So this is example of the application, which, if I switch this on, you see that behind this are still, let's say, the spatial data which were shown in this data exploration, but these are already interpreted. So you basically don't need to care about the data so much, because you already work with the informations which are derived from the data sets. And that's basically the aim of the Gisat, to allow user without the demanding analysis of the huge data sets to derive information easily. So this is just a quick overview, a quick flies through of this application. I have still some time, so I will go to this application. This one this is still a demonstrator, but it shows the integration of the Gisat with Xcube or Data Cube or Data City Cube technology, which was mentioned by Václav. And there will be a separate presentation after me from Gunnar. So the idea is to extend here the resources which we can directly used in the Gisat. And because Data City Cube is based on X-ray cube technology, so you can analyze on fly huge data easily. So one of the achievements of this period is this integration. So now we can, this is example for Limassol. You have, for example, green or public green areas here. You have some indexes calculated from the image, and you can. So these are calculated as a time series, usually quite a huge data, but you can easily basically calculate the average time series under the different green areas, and in fact studied, for example, how the vegetation evolved, if there are some unusual development, or you can compare it with some reference points. If you have something like that over the city, you can basically compare your averages with some point measurements, which you might have also the local measurements for some kind of calibration or stuff like that. So this is just example of how this integration work. Again, you can specify or reduce your analytical period as you want, and again you can export these informations out of the system if you want. So this is only a demonstration, of course, but it shows that Gisat already can work with the data which are stored in a city cube, and it can query them easily. Next application, which I will still manage. Yeah, this is just example of another complex data. This is example of how Gisat can deal with the point clouds, which are results of the INSAR measurements, which is used for the ground deformation work. So here you have really the result of the INSAR processing of the SAR images. You have a point cloud that where for each of the point you have basically history or elevation history of this point, so you can analyze the displacement trends. You can analyze the trend of this displacement. Basically, you can define a different indicators how to analyze such a movement. You can do it on the point level, or you can also use already some districts or structures. Here it is on some building blocks, and this allows you also to say something about the exposure and say something the vulnerability of the area, because when you know which assets you have in this area, you can combine it with the subsidence information you have from the point cloud, and you can analyze which of these assets are in exposure and which are vulnerable for the subsidence of the different rates. So again, you have a different indicators for that. You can have an overview how much of your assets are in a different displacement categories. And you can in fact analyze quite complex data easily, in a, let's say, easy to use friendly environment. For your understanding, the clouds data from inside are quite heavy data. So otherwise, in a different environment, this would be quite a challenging task. What I can also show you is an example of these Václav already mentioned. So just a few examples of these storylines. The environment or framework of Gisat also allows to embed the analytical elements to the normal website. So this is just example which we did some years ago for one of the projects dealing with urban growth. And this is just example that this presentation can be rather little technical, but still you can use, let's say, advanced visualization elements. So for example, this is again the WSF, but here you have it embedded in the website, and you are trying to compare the settlement area expansion in two different cities, or you can select a different one if you want. And it looks to be a little bit too small. Okay, and then you, based on your selection, we will just show the selected cities. You can see how these two cities have basically evolved in the past, and you can analyze the different history of these cities. Again, you can compare the rates between the different years. So you see, for example, here in 2003, there was really a huge development period. And you can also, Václav mentioned that in SDG context, we compare, let's say, the population increase with the urbanization increase. So you can see also something what is called expansion coefficient, so how sustainable is the growth, and you can compare this index for these two cities. You don't need to look only for the complete urban growth or just to deal with the area, but you can also dive in and see a little bit more information for a specific class. Here, for example, it's using a similar data sets which was described by Pedro as an example of algorithm hosting. So we have a urban green areas layer. You can compare the share and the total amount kind of overview for the whole cities. So kind of inventory, you can see, for example, how it relates to the city area. So you see which city and population is the size of the bubble, how basically in this set of cities, these were selected as kind of headline cities for this analysis, how basically you compare. This is the green area versus the urban fabric. So how again you can analyze some kind of clusters of the different cities, something what otherwise would be difficult to just see from the image. And then you can go back and see basically what is the similar or what are the similarities of these cities. You can also dive to map, so you can see, let's say, the different areas which evolved and which green was lost or which green was gained. And what is important also, you can have even this kind of information, how it evolved between the two periods. So which kind of consumption and formation flows you basically see in the city, which can help you to understand what is behind of these figures, because here you see just the absolute increase, but inside there could be quite a dynamic, which is a little bit illustrated here. I mean, the dynamic here is not so big because, as you see, the main part of greenery is still, let's say, remains the same, but you see that there are quite a lot of flows from agriculture, from natural areas. There were probably some kind of restoration of construction areas, and even some urbanized area or previously urbanized area were kind of renew or regreen. Here you see the, let's say, losses, and it's mainly the construction side and stuff like that. So this is just example how this could be really easily used for some kind of storytelling and discussion also with the stakeholders or on the national level, what is happening in the cities. I will finish because I'm already a few minutes above. This is another example just for the full scale land use, land cover, similar presentation. And here you can see the flows, which are obviously even more complex because we are not focusing just on green urban, but again, very powerful way of presenting how the land use and land cover evolve in the city, and you can really explore why are these flows there and try to find the reasons or drivers of these flows in the city with the discussion in the stakeholders. So I will finish here. This was just to demonstrate you what we aim with Gisat, what are its capabilities. And as I said, the presentation of some of the applications, which I did quickly, these are the, let's say, ready applications, but the Gisat is also considered for on-demand development of the new applications based on the user requirement. So thank you very much, and this was all from my side.
Thanks a lot, Tomas, for a really nice real-time presentation of Gisat tool. So let's give the floor to our last presenter, Gunnar from Brockman Consult, who will present the last part of today's webinar, activity focusing on the city cubes.
Yeah, thanks a lot, and thanks also, Tomas, for let's say your preceding talk, which gave quite a nice introduction to what I will be presenting now, which is how to build the city cubes with yet another service, which is EuroDataCube. And basically, if you showed the different ways of let's say for end users for how to access the data and the analytics in Gisat and other front ends, and you even mentioned storytelling, this will go a bit more into well, I would say into the machine room. So into generating and accessing all these different data that are around there. So I will start with a very brief introduction of EuroDataCube because we decided to integrate these two services for the benefit of the UTEP users. So EuroDataCube is also an ESA activity with the aim to establish a commercial service for basically creating a one-stop shop for EO data. So we find lots of different data sets, gridded data, derived data, products in one commercial platform. You may analyze these data and compare different data sets and also customize your workflows and create your own services. And all this you may try for free and then decide that this is a good idea. You may even ask ESA for sponsorship here. So that's the URL. You may access it. This is just a screenshot of the landing page there with the menu and the dashboard. But we will look into this in the remainder of the talk. So basically, this is EuroDataCube consists of different kind of services. There's Sentinel Hub. It's probably well known for accessing all kinds of EO data sets, including the batch processing functionality. There's this Xcube ecosystem, which this talk will be centered around, which provides data analysis and processing, but also dissemination of large gridded data sets, and this is based on this X-Array tech stack, the Python data science tech stack. And we will look at Xcube Viewer and Server because this server component is basically the backend that has been used to integrate the data that you've seen in Tomas' talk into Gisat. And then there's for GeoDB, this is the service to host and provide access to feature data, which are all kinds of in situ shapes, whatever you can think of that is not gridded and does not fit into an X-array or a GeoTIFF, a gridded data format. You see on the right, there's a huge EuroDataCube public collection registry with all kinds of Earth observation sensor data, but also derived stuff like the EA Urban Atlas, which is feature data and stored in GeoDB, or the global human settlement layer that you've probably know quite well. But also Sentinel data, raw data, all kind of things. So what is the idea here? This service EDC provides you with a simple and convenient access to these huge archives of data, and the question was, how can we leverage this to build basically customized, tailored data cubes? And I will sketch here a simple workflow, and then we may have a look into this. So the first thing is that you subscribe to the Xcube Viewer service, and this is basically the marketplace. You can see different things you can have access to, and the Xcube Viewer service is down there in the middle, and then you may use Xcube Viewer and Server interactively to prototype your application and your city cube in the EuroDataCube Jupyter Hub. So if you click on this tile, you can see there's a description and there's a pricing, and you can subscribe to this plan. There's of course also documentation and some more elaborate options for value adders that do not only want to prototype and play with this, but also disseminate what they created there further to other users and maybe even sell it. So the second step, once you have basically have your tools and the means together, then you can prototype your data and your data cube and for the city you're interested in Jupyter Hub. That's an interactive development environment, so it requires some kind of capabilities in Python programming at least. Once you're happy, you can transfer this configuration to the EDC team if you want to further disseminate this and not only use it for yourself. And with this configuration, the viewer can be published to Marketplace, and then it can be a free version, public for everyone, or can be a paid version so that other users can buy this service, or can even be a standalone deployment like the viewer at EDC viewer Brockman, or there's also Limassol CityCube we will have a look at. So then you can, from the marketplace, any user that wants to access it can deploy this, and then you get a URL and a server instance and also the viewer, and you can interact with these deployment. And then of course you can also disseminate this further, and there are just 2 examples. This is the one, the Limassol viewer that we've done for the UrbanTEP demonstrator, and then you can have even a permanent URL. It doesn't have to be one with our company name, but any arbitrary one. That's the typical workflow. So basically, that's how we can think of, let's say, technically proficient users could interact with this service. So now we can have a brief look into this. So that's my dashboard. That's when you log in, you see this, and there's this marketplace. So the first thing you could see is that there are all kind of data products and also platform services. You may subscribe to any combination of them. For this XQ viewer, of course, there's already a plan. I have subscribed to this service. There's a description, and there's an initial pricing. For 100 euros, you can start interacting with this. So once you subscribe to this, the next thing you would probably do is use this subscription, and then this is how this looks like. It's a typical Jupyter notebook. You can start your workflow, and you can open some data, and that's of course already prepared data for the sake of simplicity here in this demo. You can simply open a data set, and that's a very simple one. So that's what we call Hamburg CityCube. So we put together some Sentinel-2 data and also derived some simple indices like NDVI and also the maximum chlorophyll index, which is a water index. So that's a very simple thing to do. There's also documentation on how to access this data, subset, and store it wherever you like. So for this here, the important thing is then you can maybe subset these data and do whatever you like with it. And once you're happy, you can simply start your viewer at these 2 data sets, and then you get a viewer info. So you have a server and a viewer. And if you click there, you get your personalized viewer with the data you edit here. That's the CityCube and our subset. And you find the bands and the indices. So, and you may look at the NDVI. So there's a lot of clouds in Hamburg. That's to be expected. You may, of course, change your color map because this is bluish and you don't like that. So you can turn this to a typical green, and you can change the scale, and then you have a nice NDVI. So, and that's the time series. You can jump between different observations. That's what you get for your prototyping. You can also do this inline, so the same instance can be shown here, and then you get it inline as a viewer within your Jupyter Notebook, fully functional. So you can then go back and forth and interactively work on the data you need, and you can also stop this again. I jump over this a bit here because there are different scenarios in this example notebook. Maybe this one is interesting. The way we configure the server is that it reads a configuration file, and you can basically also not only put the raw data in there, but also do some customized configuration. So if you look into this configuration file, it's a very simple one. It tells you where the data is, and you can apply some styles. That's only a subset of things, of course, you can specify. But if you do so, and basically you read the config first, and then you start your viewer again, then it's already pre-configured. And what we did, if you look at this configuration, for example, we specified a different color bar and a value range for the NDVI, which makes sense. And if you then go to this NDVI, then you see it's already there. We don't have to do this manually. And by this means, you can basically cut out, process, and configure what you think your city cube look, or how you think your city cube should look like. And you may also combine different data. As I said, this is of course a very simple notebook, simply showing the interaction with the viewer and server. The entire data processing and data access is a different story, and it's not subject of this tutorial. But you may imagine that you can stitch together all kinds of different data, fuse data, process data, using all the services that EDC offers you. So once you're happy, basically, and you played with these tools and functionalities, and you have your requirements fulfilled, you may pass this configuration in your viewer setup to the EDC team, if you want to have this published, and not only as a temporary application, but also as a permanent one. So if you go, I have the controls here, which are a bit annoying. So basically, if you go back to the marketplace, you see here are different apps. And one of there are different ones also from other activities, GeoRise and EO4IPE Snow Browser. These are all applications that are available here to users, and most of them are free. And we put an EDC Xcube Viewer demo, and you can deploy this app here into your workspace. I've done so already. So what you find here is this ABC EDC Viewer demo. So that's the thing that then any user, if this is a free application, will find. And then this demo user starts here. And of course, for demo purposes, because EDC is a general purpose thing, there are all kind of stuff. There's an ocean color Atlantic data set in there. There's some ocean color Black Sea. There's the entire system data cube in there. But we also put this Hamburg City Cube of 2021. And there you can see it has very similar and very well-known data, but just a larger coverage. So if you now look at the NDVI, you would get, well, it's not configured, that's not good. You will get a longer time series because it's a bit larger, but this is deployed on your own resources. So it depends on the user's resources in your data cube. So there's no data. Probably there was a lot of clouds again. So that's the time series, and then you can see it covers almost a year. There are not too many cloud-free observations in Hamburg. So then you can select the one that has the little clouds, and then you get the NDVI, and then of course you can go in there and explore. Yeah, that's basically how you could publish this inside inside EDC. But what we did then, the next step is, if you want, because you see this URL up here, this is a temporary one. So if you close this, and if you close and if you log out of your workspace, then this is gone. What you can then also do is have this permanent. Where is it? This one. So this these annoying Zoom controls. I'm sorry for that. So this is what we did for the Limassol viewer. You look at the global human settlement layer, and if you zoom out, you see this is well known, the Limassol, and we put this under this permanent URL, also with a permanent server URL. So this is the API, and this is basically the interface which is used to integrate this into Gisat, or has been used here in this case. And with this data, you can, of course, also create your own, basically tailor your own, for your own city. You can tailor your own data set and your own services. And this here is, I used the different color map, and I hide these small values so that you can see basically only where this the building probability is high. You can also zoom in and out here, and there's some other data. We put some NDVI and also the HRVPP Cyprus 10 meter, so the plant index, which is a much bigger data set, but this scales quite nicely. So you may want to have a different color map as well, and then you can see this for the entire region. It is in 10 meters, and if you go down, it's a level data set, so it's a data pyramid. You can go down and you see this data is loading the high resolution parts. When you zoom in, you can also see the underlying structures here. Yeah, that would be a typical journey, a bit more technical and a bit less, let's say, end user focus. But if you want to go that way from data to service, then I think Eurodata Cube is a good option to do so. I think that's the end of my short introduction. I go back to the slides. So just to summarize, we did this full journey. So from subscription to the Xcube Viewer service, to prototyping in the Jupyter Notebook, your data and service. Then you can publish this in the marketplace, and you have it as a tile there that people can access from within EDC. But if you want, you can also have this as a persisted deployment under an arbitrary URL, and then you can use it in Gisat or also outside with a viewer. That's a very straightforward way, and we are still developing this Xcube Viewer service. So the demo is the first application that is available in the marketplace, but within the next weeks, this will be a fully commercial service that you can access to, and you can also ask either for sponsorship for. With this beautiful image of turbidity over the city of Hamburg, where Bockmann Consult is situated, I want to end this presentation. Many thanks.
Thanks a lot, Gunnar, for your presentation. If you have any questions, you want to get in touch with us, please use the web portal website or directly this main contact email. And once again, a big thanks to all of the presenters today for their contributions. I also thank all participants for joining us today. I hope that you've liked our presentations and in general the let's say the capabilities that the UrbanTEP platform offers for the users. And let me just end today's webinar with I endorse you to visit the UrbanTEP portal web page to experiment with the functionalities we presented today, browse through the available data, Gisat scopes, storylines, and most importantly, to share the info about what we do with your colleagues to, let's say, further build the user community around the UrbanTEP. So if there not anymore in regards to the questions for the presenters, I thank you, all of you, and goodbye. Enjoy the rest of the day.